In this section, we are going to continue solving systems of equations using Cramer's rule, but we have to learn how to evaluate a determinant first. These determinants are sets of four numbers, always square, and in this first case we have what is called a 2 by 2 determinant. We are going to multiply diagonals to evaluate it. 6 times -7 is -42. And the other diagonal, 3 times 2, is equal to 6. Technically, we're supposed to take that first diagonal minus the second, and instead of doing subtraction, I prefer to add. So I always change the sign of the product when I'm multiplying upward, and that way I can add these two together and get -48 for the value of that determinant. In this second determinant, the first diagonal multiplies to +42, and the second diagonal multiplies to -32, but I change the product to a +42 so that I can add these together and have 74 as the value of the determinant. In general, the product of this determinant will become AD minus BC, where AD is the product of the first or main diagonal and BC is the product of the second diagonal. Notice how I am subtracting BC because I'm multiplying upward and treating that as a negative BC. When you have a 3 by 3 determinant, there are a couple of ways to evaluate it. The first way is to bring out the first two columns, 4, 2, -1, 5, -2, and 3, and this is known as the shortcut method. And then I'm going to begin multiplying each diagonal. The first one, 4 times -2 times 5, makes -40. The second one contains a 0, so its product is 0. The third one, 8 times 2 times 3, has a product of 48, and adding across the bottom we have 8. Well, we need to do the same thing with the other diagonals, multiplying upward, changing the sign of the product each time. So this first one has a product of 16, which I change to -16. The second one contains a 0, so its product is 0. The third diagonal, 5 times 2 times 5 is 50, but I change that to a -50. And adding across, I get -66. Adding the -66 and the 8 together, we get -58, which is the value of the determinant. Now this is the way I typically will be evaluating determinants, but let me show you another way which works not just for 3 by 3 determinants, but for those of a higher order or degree. What you do when you're using this other method is you choose any row or column, preferably one that has the smallest numbers in it. So I will choose this bottom row. And you will take each element in that row and multiply it by its minor. We will have -1 times its minor, which will be a 2 by 2 determinant, -2 times its minor, which will be a 2 by 2 determinant, and then +0 times its minor. Well, we can just ignore that option because 0 times anything is 0. Now, what is this minor? The minor of an element of a row is the values that are left when I ignore the row or the column containing that number. So when I ignore the first column in the bottom row, I get the minor for that -1, which contains 4, 5, -3, and 2 if I read downward. And the other minor for -2 would exclude the values in the middle column and that bottom row, leaving 3, 1 in the first column and -3, 2 in the second column. Now, if that were it, it would be great, but there's one extra little trick we need to throw in here. We need to look at what's called a Sine Chart. Basically, I'm going to write a determinant out here on the side and alternate signs within it. This should be a minus down in the bottom center, with a +1 in the top left corner. Now we selected this bottom row, and basically we're going to multiply these coefficients by these signs. Multiplying by a positive doesn't change anything, but where that minus is, we need to multiply this -2 by a -1, technically changing it to a +2. Now we can evaluate this bottom row. we're going to have negative 1 times this determinant, which is 4 times 2 for one diagonal, minus a negative 15, which is a plus 15. Then plus 2 times first diagonal 6, minus the other diagonal of negative 3, which changes it to plus 3. This gives us negative 23 plus 2 times 9, which is negative 23 plus 18, and negative 5 is the value of that determinant. Notice how that is a little bit longer of a method, but it's the method that is required when you have 4 rows and 4 columns. You choose any row or column to expand upon, and then you multiply each element in that row by its minor, applying the signs from the sine chart. And if this was a 4 by 4 determinant, again we would start with a plus 4 up in the top left corner. But we will be using that first shortcut method each time we evaluate determinants from here on out.